Hello students, in this video we'll discuss when the internal rate of return has a unique positive solution. So let's recall that IRR, the internal rate of return, is the value I such that the net present value I equals 0. Notice I put the in quotation marks because, as we saw in previous videos, this, if I rationalize it, is actually a polynomial equation of degree with the number of periods we have. So there's going to be many solutions to this. We want to find the one that is actually most important or actually is most meaningful, because there could be complex solutions, there could be repeated solutions. We want to find the one that's most meaningful. So when I say the, I mean the most meaningful one, meaning the most plausible one. Okay? Good. So what was this, of course? Well, remember that net present value I, NPVI, is the sum, t goes from 0 to t capital, of delta t, the change in the cash inflow. It's the cash inflow minus the cash outflow. This is cash inflow minus cash outflow. Inflow minus outflow over 1 plus I to the power t. Of course, I is our cost of capital, and typically t is an integer corresponding to annual rates. So these are all annual rates. So I is the annual effective rate, or the cost of capital. Okay? So what we're going to do is we're going to set this equal to 0. So set this equal to 0 and rationalize. And so when we rationalize this equation, what we're going to get, as we saw previously, is delta 0. And then delta 0 can be hit with a 1 plus I to the power t, plus delta 1, 1 plus I to the power t minus 1, all the way down to delta t is equal to 0. And now what we're going to use a result from algebra referred to as Descartes' Rule of Signs. That's the same Descartes as cogito ergo sum, I think therefore I am. So that's René Descartes, French mathematician. So this is Descartes' Rule of Signs. And what it says if I'm given a polynomial, let's do this, given p of x, which is an x to the n plus all the way down to a1x plus a0, and this a0 can't be 0 for Descartes' rule to be true. And what you do then is these a's, these coefficients of this polynomial, can be positive or they can be negative. The number of positive roots or positive solutions is the number of sign changes. In other words, if I go from positive to negative over here, that would correspond to one sign change. If I say negative, negative, positive, that'd be my second sign change. So you count the number of times the coefficients go from positive to negative or negative to positive. You count that number of times, and that will be the number of positive roots, so that's the number of positive roots, and or is the number of sign changes less a multiple of 2. And that's sort of a technical thing that accounts for the fact that complex roots occur in conjugate pairs if these coefficients are real, like they will be for our cash flow analysis. Okay, so in other words, if I want to figure out the number of positive roots of this equation, I need to figure out exactly how many sign changes there are. So now what's a common situation we have with these cash flows? So commonly, you might have delta 0, delta 1 the first year, delta 2, up to delta k might be less than 0. So there's a common situation when the first couple of years of the project, you're getting negative cash flows. You're putting more money out, there's more outflows, more expenses than there are inflows. Think of like building a building or building a home. Initially, there's a lot of expenses, and then eventually, if you're going to try to rent out the home or do something like this, you're going to start to earn some income later on during the process. And then after this, you have what? Then you have delta k plus 1 all the way down to delta t, all those values be greater than 0. So in other words, you're in the situation where for a long time, all the cash flows are going to be less than 0. And then after that time, all the cash flows are going to be positive. In this situation over here, we have initially a whole bunch of negative cash flows, then you immediately transition to a whole bunch of positive cash flows. Descartes' rule of signs says there's going to be exactly one positive root of that equation. And that positive root will say that 1 plus I is greater than 0. And that says that that I is going to be greater than -1. So that I greater than -1, then you can actually know there will be exactly one of those in this situation, because by computing, you'll see that past this certain range, past this value of I, the function is going to be going up. So once it crosses that threshold, that positive root of the equation, you're going to be going up after that. So you can never have another I that's bigger than this particular I that is going to be a solution to this net present value I equals 0 equation. So in the situation, to summarize, in the situation when you initially, for the first couple of years, have negative cash flows, and then after that you only have positive cash flows, the Descartes rule of signs says that there is a unique solution to the net present value I equation, net present value of I equals 0 equation, and so there is a unique internal rate of return that satisfies this equation, or the unique internal rate of return that will be a solution to this net present value I equals 0 equation, and that's going to give you a way of finding out what that cost of capital has to be for your capital projects. Thank you very much.